Hello, 6th graders. We are now going to be doing the opposite, what we did in section 10.5. In 10.5, we took a number in scientific notation, and we wrote it as standard form. Now we are going to be given a number in standard form, and we're going to write it in scientific notation. So let's start with our key idea. Now you should remember from the last section that a number in scientific notation, the factor has to be greater than or equal to 1 but less than 10. And then the power of 10 has to have an integer exponent. So let's start with writing a number in scientific notation. Step 1. You're going to move the decimal, You're going to move the decimal so that the point is located to the right of the leading non-zero digit. To make it as easy as possible, the number has to be bigger than or equal to 1 but less than 10. Make the number between 1 and 10. Step 2. Count the number of spaces you move the decimal point, and this will indicate the integer of the exponent of the power of 10. Now, if your original number is greater than or equal to 10, we're going to use a positive exponent. If the number is between 0 and 1, you're going to use a negative exponent. So as you can see here, we have a number that's bigger than 10. Therefore, we move the decimal 3 places to give us 8.6. And so our integer is 3. 8.6 times 10 to the third power. Over here, we start with 0.0024. This number is less than 1. It's between 0 and 1. And so to make the number between 1 and 10, I'm going to move it between the 2 and the 4. So we get 2.4. How many digits did I move it? I moved it 3. Well, since it was less than 1, it's going to be a negative power. 2.4 times 10 to the negative 3 power. Example number 1. Google purchased YouTube for $1,650,000,000. Write this number in scientific notation. All right, so we're going to take $1,650,000,000. The first thing we're going to do is make the number between 1 and 10. So I'm going to take my decimal and I'm going to move it right there. I put it right after the leading number. 1.65. Now the zeros, we don't need any of those. They can drop off. So 1.65 times, and we have to use a power of 10, how many times would I have to multiply 1.65 times 10 to give me 1,650,000? Well, I count. 1, 2, 3, 4, 5, 6, 7, 8, 9. Because this is a really big number and it's bigger than 10, it's going to be a positive 9. So the exponent's positive. So my answer would be 1.65 times 10 to the 9th power. Example 2. The 2004 Indonesian earthquake slowed the rotation of the Earth, making the length of the day 0.0000268 seconds shorter. Write this number in scientific notation. So I write out my number. I wanted to make the number greater than or equal to 1, but less than 10. So I'm just going to take my decimal and put it right there. 2.68. Now, times 10. What would my exponent be? Well, how many spaces do you move it from here, where it was, to where you moved it, which is right there? 1, 2, 3, 4, 5. We move it 6. Would it be positive 6 or negative 6? Why would it be negative 6? Because your original number is between 0 and 1. Therefore, the exponent is negative. Why don't you write these two numbers down and do them on your own? Write each of these numbers in scientific notation. Pause the video and then see if you're right. In A, 50,000 would be written as 5 times 10 to the 4th power. I take my decimal and I move it 4 spaces. That gives me 5 or 5.0 times 10 to the 4th power. Because the number is greater than 10, my exponent is positive. Basically, if you have a really, really big number to start off with, it's going to be positive. If it's a really, really small number, it's going to be negative. Here, 1, 2, 3, 4. So my answer will be 5.06 times 10 to the negative 4 power. Example number 3. An album has sold 8,780,000 copies. How many more copies does it need to sell to receive the award? An album receives an award when it sells 10 million copies, is what it says under our picture. Now we want to write our answer in scientific notation. So you could just subtract these two numbers and write it in scientific notation. And that's what we're going to do. Really easy. 10 million subtracted by 8,780,000. That would give us 1,220,000. If we wrote that in scientific notation, it would be 1.22 times 10 to what power? What should the power be? It moves 6 spaces, so my answer will be 1.22 times 10 to the 6th power. Example number 4. The table shows when the last 3 geological eras began. Order the eras from earliest to most recent. Now we could write each of these numbers over here. We could write them in standard form, but there's a much easier way. Step 1. Here's what you do first. Compare the powers of 10. If the numbers of, since this number here, since our factor always has to be less than 10, but greater than or equal to 1, we don't need to look at these first. We can look at the powers. So we look and find the small, if we're finding the earliest, we look to see which one of these would be the oldest. Which one of these numbers would be the greatest. So since we're looking earliest is going to be the greatest number. And since we're talking about most recent, that's the least big number. So let's look. Let's start with the greatest number. Well, since 10 to the 8th and 10 to the 8th are both the same, we know those two numbers are going to be the greater numbers. Now, since we know they're the same, we can now look at the factor. 5.42 or 2.51. Which one's a bigger number? Well, 5.42. So we know the Paleozoic would be the oldest era, and then the Mesozoic is going to be the next oldest era, and then the least, or the most recent, is going to be the smallest one, and we know that because 10 to the 7th is the least power. So our last era is going to be the Cenozoic.